This is section 11.2, areas of parallelograms, triangles, and rhombuses. So I want to remind you of a few things first from section 11.1 that you read in class. So remember, we had a postulate that said the area of a square is simply the square of the length of a side. So we take a side and we square it. We multiply it by itself. So if my side is S, I'm just going to take S and square it, and I'll have the area. So say the square has a side of length 6, the area of the square equals 6 squared, which is 36. Okay? We also had two more postulates. One that was called the area congruence postulate that says if two figures are congruent, then they have the same areas. So we have two shapes that are congruent, then those two shapes fill the same area. And then the area addition postulate, the area of a region is the sum of the areas of its non-overlapping parts. So we can add up two adjacent non-overlapping areas to get the area of the whole thing, or to get the bigger area, the area of the two combined. And then we had a theorem that gave us the area of a rectangle. The area of a rectangle equals the product of its base and its height. So we would call the bottom part the base here, and the left side the height, but the left side and the right side are the same, so we could just as easily call the right side the height, and the top and the bottom are the same, so we could just as easily call the top the base, because it's a rectangle, so opposite sides are congruent. But if we take the base times the height, we'll have the area of the rectangle. So if for this rectangle, let's say the base has a length 8 and it has a height of 4, and the area is going to be 8 times 4, or 32 square units, whatever those units are. Okay, so that's the area of a square and the area of a rectangle. And we're going to use those in this section to come up with the areas of parallelograms, triangles, and rhombuses. But first, let's practice this. Complete the chart referring to rectangles, where P is the perimeter of the rectangle. So perimeter means you add up all of the sides. So if the base is 18 and the height is 3, let's just think about that. We've got 18 and 3. The area is going to be 18 times 3. What's 18 times 3? Well, 54. The perimeter is going to be all the sides added together. Well, for a rectangle, the perimeter for a rectangle, since opposite sides are congruent, it's just going to be 2 times the base plus 2 times the height. So I've got the base twice and the height twice. So I take 2 times 18, which is 36. So I'll write it out step by step. 2 times 18 plus 2 times 3. So we've got 36 plus 6, or 42. So the area, the perimeter, I'm sorry, is 42. So all 4 sides added together. What if, and each column is a separate problem, what if the base is 7.5 and the perimeter is 39? So we've got 7.5, 7.5. The perimeter is 39. That means 39 is going to be 2 times 7.5 plus 2 times the height, whatever the height is, using the same formula I just used for the perimeter down here. Well, 2 times 7.5 is 15. I subtract 15 from both sides, then I'll have 2h equals 39 minus 15, which is 24. So h is 12. So that's the way I figure out the height if I know the base and the perimeter. And then the area I can find using the base and the height. I just take the base times the height. And 12 times 7.5 is going to be 90. Okay, then separate problem, what if the base is 4 and radical 2 and the height is 5 radical 2? So let me make some room. I'll do this one in a different color. If the base is 4 radical 2, the height is 5 radical 2. In this case, the height is actually bigger than the base, so my picture is horrible. So let me draw a new one where it's a little more clear that it's taller more than it is wider. Okay, because 5 radical 2 is bigger than 4 radical 2. But it doesn't really matter, because the area is just going to be multiplying the two. I'm going to take 4 radical 2 times 5 radical 2. So remember, multiplying numbers like this, I can multiply the numbers on the outside, 4 times 5, which gives me 20. And then the radical 2 times radical 2 is radical 4. The radical 4 is just 2, so this is just 20 times 2, which is 40. So that's the area. The perimeter, again, I'm going to take 2 times the base plus 2 times the height. So that will be 8 radical 2 plus 10 radical 2, which is 18 radical 2. So you should have that chart written down in your notes. You'll do some more problems like that in class. So now let's move on to some more shapes. Let's start with the parallelogram. So we know squares and rectangles, which are special types of parallelograms. What if we just have a generic parallelogram? How do we find the area? Well, this theorem says the area of a parallelogram equals the product of a base and the height to that base. So area equals base times height. That should look incredibly familiar. That's exactly the formula we had for a rectangle, except now the height is not a side of the parallelogram. This would be the base down here, which would be equal to that one up there. The top or the bottom could be called the base. But the height is a perpendicular line. So I could draw one here. If that's perpendicular, then that is a height of the parallelogram. I could also draw it out here and extend my side. That's also a height, and it's going to be the same as the other one. I could pick any points on, say, the top and draw a perpendicular line to the bottom, and that would be a height of the parallelogram. So it's not a side of the parallelogram, because the parallelogram does not have to have perpendicular sides. It would if it was a square or rectangle, but in general it does not have to have one. So I want to convince you that that is, in fact, the formula for the area of a parallelogram. And the way to do that is to use what we know. And we know the area of a rectangle. So the way that I just sketched these heights on my parallelogram is actually going to be useful, because we can show that this triangle over here, which is part of the parallelogram, is equal in area to this triangle over here, which is not part of the parallelogram. I can show that they're equal in area because I can show that those two triangles are congruent. And then the theorem that says that congruent figures have the same area will tell me that they're equal in area. So that means if I call this, say, area 1, and this is area 2, and this is area 3, the area of the parallelogram would equal area 1 plus area 2, right? I've just taken the whole parallelogram, split it up into that triangle, and then this funky trapezoid that I'm calling area 2. But I can show, because those two triangles are congruent, which I could do either by hypotenuse leg, because the hypotenuses would have to be congruent, and these heights would have to be congruent, or I could do it with angle side if I wanted to, with the parallel lines finding me some angles that were congruent. Those two triangles are congruent, so that means area 3 going to be equal to area 1. So the area of the parallelogram could also be written as area 3 plus area 2. But area 3 plus area 2 is the area of a rectangle, which is going to be base times height, b times h. So that's why the area of a parallelogram is simply the base times a height to that base, because I can take that parallelogram and sort of transform it by shifting things around to look like a rectangle and get the same formula. So that formula actually follows from the theorem for a rectangle. For example, find the area of this parallelogram. So I have not given you the height. I've given you the two sides. I've got 10 as the base, and 8 is the other side of the parallelogram, the slanted one. But I've given you that an angle of this parallelogram, this angle down here, is 45 degrees. And this height that I drew gives me a right angle. So that means I've got myself a 45, 45, 90 triangle. And where I know the hypotenuse, so let me redraw this triangle down here. I got 45. I know the hypotenuse is 8. How do I find the leg? The leg will be the height of my parallelogram. How do I find it? Let's call it h. So h is going to be 8 divided by radical 2. That's our ratio for 45, 45, 90 triangles. So I got to multiply by radical 2 over radical 2 to get rid of that on the bottom. I get 8 radical 2 over 2, which becomes 4 radical 2. So the height is 4 radical 2, and the base is 10. So the area is going to be base times the height, which is 10 times 4 radical 2, which is 40 radical 2. So I used what I knew about 45, 45, 90 triangles to find the height. And then I was able to find the area. Now how about a triangle? The area of a triangle equals half the product of a base and the height to that base. So for a parallelogram, it was equal to the product of the base and the height to that base. Triangle is half of that. Half of the product of a base and the height to the base. And so instead of a equals bh, it's a equals 1/2 bh. That's a triangle. And the reason that is the case is because we can take our triangle and we can make a parallelogram around it where I draw a parallel line from this top vertex, a line that's parallel to the bottom side of my triangle. And then for a parallelogram I need another parallel line, so I'll draw a parallel line through this vertex that's parallel to the left side of my triangle. So I'm making a parallelogram where the original triangle turns out to be half of the area of the parallelogram. I could show that if I could show that these two areas are the same. And I could do that if I could get those two triangles congruent. Well, they share this side, and we've got parallel lines. So I've got alternate interior angles there, and I've got another pair of alternate interior angles there. So I've got angle, side angle, and I've got two congruent triangles. That means the area of the parallelogram equals, if this is the base, and I draw the height, the area of the parallelogram is going to be base times height by the theorem we just used before, but the area of the parallelogram is going to be 2 times the area of the triangle. That means the area, 2 times the area of the triangle equals the base times the height. So dividing by 2, the area of the triangle equals 1/2 of the base times the height. So that's where that formula comes from. It actually comes from the theorem for a parallelogram, which came from the theorem for a rectangle, which came from the theorem for a square. So all we had to do was state the area of a square as a postulate, something that we assumed to be true, and from that we were able to prove formulas for every other type, for a rectangle, a parallelogram, and now a triangle. So, for example, find the area of a triangle with sides 8, 8, and 6. Alright, if I've got a triangle with sides of 8, 8, and 6, that means two of my sides are equal, so it's going to be an isosceles triangle. In order to find the area of a triangle, I need to know the height, and I don't have a height here. Heights are altitudes in triangles. They are perpendicular because that's the way we measure a distance, is with a perpendicular line. So I've got to draw a perpendicular line. Because this is an isosceles triangle, I'm able to say that that altitude is also going to be a perpendicular bisector. So this is also that's going to be 3 there and 3 there. The 6 is going to be split up evenly, which means I then have a right triangle on each side here with 3 and 8, and I can find the other side, which will be h, the height, using the Pythagorean theorem. And so 3 squared plus h squared equals 8 squared, so 9 plus h squared equals 64, and h squared equals 64 minus 9, or 55. So h is the square root of 55. And can we simplify the square root of 55? Nope. So that's the height of the triangle. Area of a triangle is 1/2 of the base times the height. What's the base here? That's 6, because that's the side that we drew the altitude to. So 6 times the height, which is radical 55. Well, 1/2 of 6, 1/2 times 6 is 3. So that's simply 3 radical 55. And as long as that's simplified, I'm done. And it is simplified. There are no perfect squares that divide into 55. So we're done. So sometimes I'll have to find the height, which means I'll have to draw an altitude and find the length of that altitude. But once I draw that altitude, that's determining which side of the triangle will be the base. It's the one that I drew the altitude to, the one that is perpendicular to the altitude. And last one, a rhombus. The area of a rhombus equals half the product of its diagonals. So a rhombus is another special type of parallelogram. We could find the area of a rhombus using the formula for a parallelogram, the base times the height. But we can also find it with this formula, 1/2 of the two diagonals multiplied together. So let's say that this is D1, diagonal 1, and this is D2, diagonal 2. If I take those two and multiply them together and take half of that, I will have the area of the rhombus. Why? Well, because a rhombus is really a combination of two congruent triangles, where, let's say I use this as one triangle, and this is the other one. Those are congruent because of the nature of a rhombus, but that also means that the bases of those are both the same. They're both D1. And the altitudes of both of those are going to be equal. The heights of both of them are going to be equal. They're both going to be half of D2. So if I want the area of this, I'm going to take the area of the yellow triangle plus the area of the pink triangle, which means I'm going to take 1/2 of the base, D1, times the height, which is going to be half of D2. These are all multiplied together. Plus I'm going to take 1/2 the base of the pink triangle, which is also D1, times the height of the pink triangle, which is also 1/2 of D2. And so then I'm going to end up with 1/4 of D1 D2, 1/2 times 1/2 is 1/4, plus 1/4 D1 D2. If I add those together, I essentially have 2 times 1/4 of D1 D2, and the 2 times 1/4 is 2 over 1 times 1/4, which is 1/2 D1 D2, which is exactly what I said it would be, half the product of the two diagonals. So I'm just trying to show you that these formulas aren't just coming from nowhere. They're actually following from what we knew before. We found the formula for a rhombus by using the formulas for triangles. We found the formula for a triangle by using the formula for a parallelogram. We found the formula for a parallelogram by using the formula for a rectangle. We found the formula for a rectangle by using the formula for a square, which is what we assumed to be true. So for example, find the area of the rhombus, where I know half of each of my diagonals. This one is 4, so that means this one is 4. That one is 6, that means that one is 6, because remember, the diagonals of a rhombus bisect each other. So this should be easy. The area is half the product of the two diagonals, so it's going to be half of 12 times 8, the whole diagonals. Okay, well, half of 12 is 6, so this is the same as 6 times 8, which is 48. And that's the area of my rhombus, half the product of the diagonals. So here are your immediate practice problems, which are exactly like each of the 3 examples I did. So just look back at your examples and just do the same thing I did. Except the one for the triangle is even easier because I gave you the height. So find the areas of the figures below, draw the pictures, and show your work for each one. You'll be turning these in class. Number 1, the parallelogram. Number 2, the triangle. Number 3, the rhombus. Use the formulas I gave you, plug things into the formulas, and simplify your answers. And that is the end of section 11.2.